let's learn the definition of modular arithmetic. Definition of modular arithmetic. Modular arithmetic is a system of arithmetic for integers when numbers are rotated round a circle. So we write modular arithmetic is a system of arithmetic for integers when numbers are rotated in a cycle. And under modular arithmetic, with a specific mode n, the only numbers used are 0, 1, 2, n minus 1. That is, if you are working with a specific mode 4, the only numbers we'll be using to represent the entire integers are 0, 2, 4 minus 1, 3. That is digits 0, 1, 2, and 3. Let's look at an example. For example, we look at the mode 4. Now, we said modular arithmetic is a system of integers when numbers are rotated around the circle. So here we draw a circle. Numbers used in mode 4 will be 0 to 4 minus 1, 3. That is, we have digits 0, 1, 2, and 3. So we take the digits 0, 1, 2, 3 round the circle. So we have 0, 1, 2, 3. Now here, it does not mean we don't have integers greater than 4 in the mode 4. That is, we can have 10 in mode 4, but the only difference is that it has to be rotated around the circle. That is, if I'm going to count round 3, I'm going to 4, so 4 is going to come back to the 0, then 5, 6, 7, and it keeps on going round the circle like that. That's what it means by a system of arithmetic for integers when numbers are rotated in a cycle like this. So here, we write 7 is equivalent to 3. Then put the mode we are working with, mode 4. Recall, we said the only numbers used are 0 to n minus 1. Here we are using mode 4, so the only numbers we'll be using 0 to 3. So for any number greater than 4, we have to use digits from 0 to 1 to represent all other integers. So here we have 7 is equivalent to 3 in mode 4, where this symbol is called congruence, and means equal to. Now, what if they give you a big number? You want to figure out what digit is going to represent from 0 to 3 in this mode 4. Let's say you have 73, and you want to give it in this mode 4 to represent digits from 0, 1, 2, and 3. Here, all we have to do is divide it by 4, and we'll pick the remainder. Now, 4 in 73, 4 in 7, we have 1 remainder, 3. 4 in 33, that gives us 8, which is 32. So we have a remainder of 1. That is 73 is equivalent to 1 in mode 4. Just like we have 7 in mode 3. This 3 can also be gotten by dividing this 7 by 4 and picking out the remainder. When you divide 7 by 4, you have 1 remainder 3. So that's why we have 7 equivalent to 3 in mode 4. So, modular arithmetic is sometimes referred to as remainder arithmetic. Since any number we pick is equivalent to the remainder when that integer is divided by the mode. Example, if you are given a number 45, I want to represent this 45 in a number in mode 8. What we have to do is divide this 45 by 8. Now, how many heads can we see in 45? That's 5, remainder 5. That is, 45 is equivalent to 5 in mode 8. So that's what modular arithmetic means, and that's how to convert integers to different modes. Thank you.